8.6 Proportionality Theorems. The triangle proportionality theorem says if a line parallel to one side of a triangle intersects the other two sides, then it divides the two sides proportionally. So what that means, if you take a look at your picture, is that we have our triangle here, and then we've got parallel lines. So as long as our triangle is being split by parallel lines, then the ratio of QT over SU is equal to the ratio of TR over UR. You could also do it as the ratio of QT over TR is equal to the ratio of SU over UR. The converse of the triangle proportionality theorem says if a line divides two sides of a triangle proportionally, then it is parallel to the third side. So remember, converse kind of means backwards. So all this is saying is if you can write the proportion, so we're going to take RT over TU equals QT over SU. If that proportion is true, then we can prove that these lines are parallel. Three parallel lines theorem. If three parallel lines intersect two transversals, then they divide the transversals proportionally. So again, we've got a parallel line, parallel line, parallel line, and they're cutting two transversals. So we could do the proportion that UW over VX is equal to Y or WY over XZ. You could also do that UW over WY is equal to VX over XZ. And then last but not least, the triangle angle bisector theorem. If a ray bisects an angle of a triangle, so first of all, you have to have an angle bisector. Then it divides the opposite side into two segments. So we have this segment and this segment, whose lengths are proportional to the lengths of the other two sides. So AD would be proportional to CA, and DB would be proportional to CB. But keep in mind that's only true if it's an angle bisector. Example 1. In the diagram, QS is parallel to UT. We know that RS is 4, ST is 6, and QU is 9. What is the length of QR? So RQ or QR is right here. I'm going to put an X. Now, given that we know these lines are parallel, we know that these sides have been cut proportionally in our triangle. So there's actually a couple ways we can set this up. The first proportion you could use is you could say X over 4 is proportional to 9 over 6. Or I've seen a lot of students do, well, X over 9 is proportional to 4 over 6. So instead of going from like side to side, side to side, students will go top to bottom, top to bottom. The only thing you cannot do is you cannot say X over 6 equals 4 over 9. That's like a crisscross. That will not work. That is a non-correct proportion. At this point, I'm going to cross multiply. So 6x equals 36. And then I'm going to divide both sides by 6. So x equals 6. If I were to solve the other one, you're still going to get 6x equals 36, and then divide by 6. So you still get the same answer.